Hello and welcome back. And in this video, we're going to be looking at another linked list related interview question. And this one is basically, again, another variant of the last one. And the condition is that you are required to find the start of the cycle in the linked list, in a singly linked list, without counting the length of the cycle, okay, or number of nodes involved in the cycle. So in the last video, we saw how we can actually first detect the loop and then count number of nodes in there inside the loop, and then basically find where the start for linked list for the linked list cycle is. So that whole process was one variant, but your interviewer, when you solve that question, your interviewer may ask you that, can you solve this without using the count? So that's the question. So basically, we have once again the same example: 1, 2, 3, 4, and 2, and the start of the linked list cycle is start of the cycle is at 2. Okay, so that's what we need to find out. So let's go ahead and pause the video here. Think about this. We're going to be taking similar approach just to hint you, and then we're going to look into the solution. So please pause the video here and come back to see what we've got for you as a solution. I hope that went well. So let's go ahead and take a look at the solution that we got. But before that, let's take a look at visualization first. So in order to basically find the cycle, what we're going to do is we're going to take 2 pointers, once again, fast and slow, and we're going to move them the same way we were, excuse me, we were moving. Slow pointer moves next element, and the fast pointer moves next to next. Okay, so we're going to move in a similar fashion until we find that there is a loop. So this is where our discovery for the start node starts. So what we're going to do now is basically we're going to take our slow pointer and point to the head again, okay? And then we are going to basically increment fast and slow one by one next to it, okay? Remember, we have already found our loop. Now we are incrementing both at the same pace, just element dot next. That's what we are doing. So we're gonna just keep doing it until both the pointers start pointing at the same node, and that's gonna be the start of the cycle, where the cycle in the singly linked list starts. Okay. So hope that was clear. Let's take a look at this in the lab. So we are going to basically create a simple function. So I've got this setup here. We have a list, and we have added some elements in the list, and we've created a cycle at 3 here. Okay, so we have our function find cycle start, and what we're gonna do first, we're gonna get our slow pointer point to list, and fast pointer point to list as well. And the list is basically the route that's been provided to us. So it's just the head element that's been provided. Now we're going to check while slow is not equal to nil and fast dot next is not equal to nil. Now we don't need to check fast because we are already checking slow, and we know that if slow is going to be nil, that means it's going to exit, and fast and slow are pointing to the same value, same memory address. So only one check would be suffice. Fast dot next we would have to check, and we'd also have to check fast dot next. Okay, is not equal to nil. So we're going to go inside, and we're going to assign our slow pointer to slow dot next, and fast pointer to fast dot next. Okay, and then we're going to compare. We're going to say slow dot data, is it equal to fast dot data, basically to check if we found a loop. Okay, and once again we're going to do another while loop here, and what we're going to do is we're going to first assign a slow pointer to head, which is list, and we're going to say while slow dot data is not equal to fast dot data. So while those two nodes are not equal, increment both of them one by one, like so. Okay. So at the end, what you're going to get is slow and fast pointing to the same element, which is going to be the start of the cycle. So we simply say return slow. Okay. So you can return slow or fast, either one, because both are pointing to the same variable. And because we are returning optional node, we can return either slow, or if the slope goes through, we could not find any cycle, we simply return nil. Excuse me. So let's go ahead and run this and see if we get 3 as a start. And there you go. We get 3 as the start, and we know that that's where we actually added the cycle. So we were able to detect where the cycle was. Okay. So hope that was actually clear with the visualization and the code. Take a look at it again if it's not super clear, and once again put some print statements to see, or debug points to see like how it's executing. Time complexity for this one is O of n square because you're looping twice. So for big input, it's going to be n time, and n times m is still going to be O of n square. Okay, so O of nm or O of n square is actually going to be O of n square is actually more appropriate because we are iterating over list twice, the entire list. We don't have two lists. So O of n square is the correct one. Okay. So hope that was hope you like this video, and I will see you guys in the next video. Thank you.